Alright, this video is going to cover the 2019 question number 2 FRQ from the AB exam. Let's go ahead and show that really quick. Okay, so you're given a table, and let's go ahead and cover the scenario. The velocity of a particle P moving along the x-axis is given by the differentiable function Vp. Don't get thrown off by the subscript variable there, okay? I'm just going to say V. I'm not going to say subscript P, but that's no different than just being a V. It's just what they decided to call it. Okay, where Vp of T is measured in meters per hour and T is measured in hours. Selected values of Vp of T are shown in the table above. Okay, remember, this is the velocity, okay? This is the velocity table, not the position. Okay, particle P is at the origin at time t equals 0. That's an initial value. That's going to be important at some point in this question. Okay, and then they tell you Vp of T is measured in meters per hour and T is measured in hours. All right, so question A says, justify why there must be at least one time t for the interval from t is 0.3 to 2.8 at which Vp prime of t, the acceleration of the particle, okay, so the derivative of Vp is acceleration, equals 0 meters per hour per hour. Okay, this is a mean value theorem question. Okay, we're trying to show that a tangent line is 0, okay, which means we're trying to show that the secant line is equal to the tangent line. Okay, so that's the mean value theorem. Again, it's in your foldable. Okay, f prime of c equals f of b minus f of a over b minus a. This is the key right here, that you must state this. Okay, so before we go on to answering the actual question, okay, the first thing we need to say is Vp is differentiable and continuous on that interval, and that interval is 0.3 to 2.8. Okay, if you don't say that, you'll lose a point there, and I'm not sure if you lose them all, but you must say that. Okay? All right, now what I'm going to notice in my table is, lo and behold, I got two y values that are the same. Okay, so I'm going to pick those two as my 2 points to show the slope of the line between here and here. Okay, so we're just going to go ahead and say this is f of b, so Vp of 2.8 minus Vp of 0.3 over 2.8 minus 0.3. Okay, that's just f of b minus f of a over b minus a. Okay, we know Vp of 2.8 is 55, and Vp of 0.3 is 55 over 2.8 minus 0.3. And that's going to give me 0 over 2.5, which is 0. Okay, and then it says to justify the answer. So we're going to say by the mean value theorem, there is a value c where c is between 0.3 and 2.8 such that Vp prime of t equals 0. Excuse me, Vp prime of c equals 0. All right, question B. Question B is asking us to use a trapezoidal sum with 3 subintervals from 0 to 0.3, from 0.3 to 1.7, and from 1.7 to 2.8. to approximate the value of the integral 0 to 2.8 Vp of t dt. So we'll start off with writing that integral. 0 to 2.8 Vp of t dt is equal to, and we have our three intervals, from 0 to 0.3, from 0.3, 0 to 0.3, from 0.3 to 1.7, and one from 1.7 to 2.8. Okay, remember the area of a trapezoid is 1/2 the base times the height. Okay, excuse me, that was not the formula at all. The area of a trapezoid is 1/2 times the height times the sum of the bases. Sorry about that. Okay, so in our first example, it's going to be 1/2, so I'll write that down, times the height. The height is this right here. Okay, this is my height. These are my bases. Okay, the height is going to be along your x-axis. So the height is 0.3, and then the sum of the bases are 0 and 55. Now remember, when you're doing a trapezoid, you're going to use this one once, and these two guys twice. Now, we can't shorthand this because these intervals are not equal from here to here, here to here, and here to here. Not the same. So we're doing each individual trapezoid instead of just adding up all the bases. All right, so my bases are 0 plus 55. Then my second trapezoid, 1/2 times the height. Okay, the height of this one is from 0.3 to 1.7, which is 1.4, times the sum of my bases, 55 plus negative 29. Or just 55 minus 29. And then my last trapezoid is 1/2 times the height from 1.7 to 2.8 is 1.1, times the sum of my bases, which are again negative 29 and 55. So negative 29 plus 55. So I get out my calculator. I'm going to do all this math in my calculator. Okay, so it's 0.5 times 0.3 times, I'm doing this one right here. We're just going to say 55. We can do that in our head. Plus, I'm going to just use parentheses the rest of the way, 0.5 times 1.4 times 55 minus 29, not going to do that in my head, plus 0.5 times 1.1 times negative 29 plus 55. Go ahead and close that parenthesis, and we get not the right answer. Where did we go wrong? 0.5, 0.3, 0 plus 55, 1/2, 1.4, 55 minus 29, 1/2, 1.1, negative 29 plus 55. Let's go ahead and go back over that. $55 minus 20. Ah, there it is right there. I don't have a 29 right there. Second insert, a 9. Glad I didn't have to start this video all over again. 40.75 is the correct answer. Okay, that's an approximation. Okay, we did a trapezoidal approximation on that one. All right, let's go to question C. Question C says a second particle, particle Q, also moves along the x-axis, so that its velocity for time 0 to 4 is given by VQ of t is, and you're given a function. Okay, remember this is a calculator question, so that's going to help. You're obviously going to type that in at some point. Meters per hour. That is our velocity function. Find the time interval during which the velocity of particle Q is at least 60 meters per hour. find the distance traveled by particle q during the interval when the velocity of particle q is at least 60 meters per hour. So we go into our y equals and go ahead and type that function in. Okay, and then I'm going to graph it. We're looking at the window from 0 to 4, and I arbitrarily did 0 to 100. I have no idea if that was is good enough. It turned out it was. It was arbitrary. I guessed on that number. Here comes my graph of my function. Let me dim this a little bit so you can see it. Okay, and I want to know, find the time interval during which the velocity of particle q is at least 60 meters. Okay, so I'm going to graph the line y equals 60 right here. And where it intersects is where the velocity is 60. Okay, so we got two spots here. We intersect here and we intersect here. And then the question later on says find the distance traveled when the velocity is at least 60. That's all the distance under this curve right here, the area under that curve. Okay, so I need to find these 2 points. Most likely they are going to be wacky decimals. Okay, so the first thing I'm going to do is second calc, option 5. I'm on the blue curve, enter. I'm on the red curve, enter. And then my guess, I move my cursor close to my guess. And it's going to tell me that it intersects at 1.8661815, blah, 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 right? So the first thing I'm going to do is I'm going to write down VQ of t is equal to 60 when t is equal to 1.86618. I'm just going to write that down. And I'm going to go ahead and store that in my calculator as A. Okay, because I don't want to have to write down that whole decimal. So I'm going to store it. I don't want to round it now. So I exit out of my graph. I hit my store button, which is right down here. It should say answer. And then I'm just going to pick alpha A and store that value in A. And then I'm going to say or at t equals, go back to my graph, okay, because I got to get this other value where we're 60 meters per second. Is it per second or per hour? Per hour. So second calc, option 5 again. First curve is blue, second curve is red. And I can just move my cursor. If I don't move my cursor, it's going to give me that same answer. I want to get this one. So I can either move my cursor or just guess that it's 1, 2, 3. It's in between 3 and 4, so I'm just going to say 3.5. It moves the cursor over there. It's 3. Let's go ahead and write this down. 3.51917, and I'm going to store that in B. I'm going to need that for my integral later on. So I exit out of this. I hit store alpha B, and I got those two values stored. All right, so I can now say that VQ of t is greater than 60, because my question here says, find the time interval during which the velocity of particle q is at least 60. At least means 60 or greater meters per hour. Okay, so VQ of t is greater than 60, greater than or equal to. Should I put an equal sign there? Let me think about that for a moment here. Yeah. Greater than or equal to 60 on the interval A to B. And we've identified A and B. If you want to write your two numbers here, you can do that also, but we've already identified that they're A and B. Okay, the second part of that question is saying find the distance traveled by particle q during the interval when the velocity of particle q is at least 60 meters per hour. Okay, we're going to go ahead and do the absolute value of that function just so we can, because we want total distance traveled, okay? The total distance traveled, not the net distance. So we're going to integrate from A to B, and then that's going to be the function absolute value of VQ of t dt. And then this is just going to be a calculator entry. Okay, so we're on our, we can clear this out for a minute. Okay, we're at math, and then we're going to integrate, so it's option 9. And we're going to go from A to B, so it's alpha A, move my arrow up, alpha B, and then I already have that function typed into my y1, so I'm just going to hit math, arrow over the number to get my absolute value bars, and then inside my absolute value bars I'm going to hit alpha F4 to get the y1 function, and then I'm going to put an X in my box here and hit enter, and we get 106.108 or 106.109. And that's does it ask us for, well, it's distance traveled, so it'd just be meters. I don't think it really asks for include units. It doesn't state it, but you can. Not wrong, but don't put something that is wrong. So if it doesn't ask for units, you don't need to put it. All right, the last one, D. At time t equals 0, particle Q is at position -90. Remember, particle P, if you go back up here at time t equals 0, is at the origin. Okay, that's probably going to come into play here. Using the result from part B, okay, that was your estimate of the distance traveled using a trapezoidal method, and the function VQ from part C, that's this function right here, approximate the distance between particles P and Q at time t equals 2.8. So we need to find their position at time 2.8, and then the difference of that would be the difference between the distances between the two particles. Okay, so here's what we know. Let's talk about particle P first. Okay, particle P, which is x of P at time 2.8, is equal to the integral from 0 to 2.8 xp of t dt, which we got from this right here. Okay, we found that integral from 0 to 2.8 vp of t dt was 40.75. So the good news is there's not that much work to do on that one. For particle Q, okay, we know that the integral from 0 to 2.8 vq of t dt is equal to, this is the fundamental theorem of calculus part 1, vq of 2.8 minus vq of 0. And we know this value. Okay? So we can use our calculator to find this value, and we know this value. So I'm going to get out my calculator and type this integral in. Remember, VQ of t is already stored in y1. So it's math option 9, 0 to 2.8, and then it's going to be what's in y1. So it's alpha F4, option 1 there, dx, and I get 135.9376. So I'll go ahead and write that down here, 135.9376. I'm just writing it down. I like to write it down to 4 just to play it safe. Is equal to VQ of 2.8 minus, and remember, VQ of 0 was given to us in the question right here. Okay, at time t equals 0, the position is at -90. So minus -90, which is going to make a plus. All right, now it's just basic algebra. Move this to the other side. So I'm going to subtract 90 from both sides. Do that in my calculator and get 45.9376 is the position of particle Q at time 2.8. So now that doesn't answer the question. At time 2.8, particles P and Q are, and then we just subtract 45.9376 minus 40.75. Position of particle Q minus the position of particle P minus 40.75 equals 5.1876. You can either answer 5.187 or 5.188 meters apart. Okay? All right, so that wraps up FRQ number 2. Have a good day.